Yeah, you can see it. Cool. Hi, everyone. Thank you, Caroline, for the introduction. I'm so excited to be here today. Um, like she said, I work on Reddit's ads backend team, and today I'm going to talk about how Reddit built its new ad serving system using Go, and I'm going to share some experiences that we've had, some lessons that we've learned while working on this. Learning from each other's experiences is very important. The Go community is now more than 1 million developers, and a lot of them have just started using Go. And the best thing we can do is share our experiences and help each other and learn from them. I experienced that firsthand last year, which was my first GopherCon. It was my first time. I had just started using Go. We had decided to use it in this new system that we were going to build. And I came here, and I spoke to people, attended talks, learned so much, and a lot of those things helped me out over the last year. And today I'm here to share some of my own experiences so that maybe it'll help you guys when you go and work on your next Go project. The things we're going to talk about today, we're going to start with a quick introduction to Reddit for those who don't know what it is. This is Snoo, the Reddit alien mascot, who's going to give us company through this talk. Then we're going to quickly do a deep dive into the architecture of this new system that we've built. And the most important part is we're going to talk about the experience that Reddit has had. I'm going to share some lessons that we've learned and the challenges that we have faced while working on this. So real quick, let's get started. How many of you know what Reddit is? Show of hands. It's a lot of people. How many of you are regular users, like once a week? That's a lot of people. For those who don't know, Reddit is a place where conversations happen online. It's where you go and find communities around anything that you find interesting. It's called the front page of the internet. That's how it started up. So in terms of numbers, it's a very popular platform. Very, very popular website. We have a lot of monthly active users, more than 300 million. A lot of communities. We get a lot of posts every month, a lot of views every day. So the main thing here is any system that we build in service of this platform needs to be made to scale with this. So one such system that I'm going to talk about today is ad serving. Ad serving is everything that happens in the backend from when you go to a page on Reddit and from when you get content back along with the ads in it. So the part where ads are selected, all of those things are a part of ad serving. And then it also includes some post-processing that happens afterwards. This talk is not about ad serving. In case you don't really know much about it, it's fine. Most of the things I'm going to talk about are relevant across all business domains. But just to give some context, some of the challenges that we have with ad serving, we have the scale. So we have to, every single request that goes to Reddit, most of those things come to our ad server. So we have to handle those. And we have to be really quick. We don't want ad serving to be the thing that slows down how quickly we can get the responses back to our users. We want it to be among the fastest. The SLA that we've set for ourselves is to respond back with an ad whenever asked for in under 30 milliseconds. We run an auction in real time for every request that we get for ads. So this is going through all advertisers who are interested in showing ads and finding the most high-quality one that has a good high bid amount that wins the auction. And then we want to make sure these ads that our advertisers are running are paced well. So we're not showing a lot of ads of the same advertiser. We want to allocate ads optimally depending on what our traffic looks like and a bunch of other factors. So before we built this new system that I'm going to talk about, this is what things looked like. So we had, whenever a user went to reddit.com, the Reddit backend, which is a monolith that we are slowly breaking into small microservices now, the backend would make a call to a third-party ad server. And this third-party ad server would return an ad or a few ads, and those would get injected in the responses that were sent. So this is pretty standard. Most websites do that. But as we scaled, we realized that this wasn't going to work well for us. There were a few reasons. This arrangement that we had with calling out the third-party ad server was often slow. It would slow down our overall request often. It was not very customizable, so we couldn't make the changes that we often wanted because they weren't supported. And then it was also very operationally hard to figure out what was going on. We didn't know how things were implemented. We didn't have the same kind of control over the quality of ads that could be shown that we would have if everything was in-house. So last year, we decided to change this by building our own ad server, and we formed a team of 3 people. I was one of them to make that happen. So we got to work, and we started with building the right infrastructure that we wanted for it, and then we worked on adding the services that we needed, and then rolled it out to production. This system is in production today, and so in the next few slides, we'll look at what it looks like right now. So some of the components that we've used in the ad serving infrastructure, they're on the slides here. I'm not going to go into a lot of details on what they are. I think they're pretty commonly known. A couple of things I want to call out. We use Thrift for all our RPCs. Apache Thrift, for those who don't know, has been around since around 2007. It was one of the first RPC protocols that came out. gRPC kind of succeeded that later. And Reddit has been using Thrift since the very early beginning. So any new system that we are going to build also needs to support that. We need to be able to talk to some of the older services using Thrift. And the other thing, we use RocksDB for data storage in real time. RocksDB is an open source key value store that was open sourced by Facebook. And it's an embeddable data store. You can embed it with your services, so you avoid the extra network hop in trying to get data. And it's optimized for high throughput reads and writes. And it was a fork of LevelDB with some improvements that Facebook released. And then we decided to use Go as the main sort of backend language powering all the latency sensitive services that we were going to build. This is pretty obvious that we would use Go in hindsight, but for Reddit, this was a big change. It was the first time we were going to use Go in production. Most of our existing services are written in Python. There is some Java and Scala for data pipelines. So this was the first time Go was going to be used. And we wanted to make sure Go would be a first-class citizen in the set of languages that Reddit had. We wanted to make sure it could support everything that was expected from a service at Reddit. So now let's look at what this system looks like today. We built it, it's in production, and it's running. So now when a user goes to a page on Reddit, instead of calling out to the third-party ad server, we make a call to a service called ad selector. This is the first service in this ad serving infrastructure. It's a Thrift service which receives this call. We call it get ads. And its job is to find ads and return those back. In order to do that, it makes another call to a service called the enrichment service, which gives more data and more information about that request, about the user, and essentially everything that it needs to find the right relevant ads for that request. Once it has that, it goes through all the ads that are running and finds the best one and returns that back. Additionally, it also logs that out to Kafka. We use Kafka for all our event logging, and we use this data for reporting and billing and other things. Now, once this ad is shown to users, there's some post-processing that needs to happen afterwards. So HTTP request fires from the user's browser that tells our event tracker, which is another service that we have, that an event that we wanted to happen has indeed happened. So in this case, we wanted an ad to be served, and this is confirmation that the ad got served. And the event tracker logs that out to Kafka, and we are done in this serving loop. So we are now done interacting with the users. There are a few other services running asynchronously that are helping these other services run in the right way. So one such loop is the event stats Spark streaming job. So this job is always running, pulling data off of Kafka, joining things, and injecting, updating the enrichment service. So this is like writing to the enrichment service and giving it more information to get better about each decision. So this is essentially like a way for us to learn from our experience and keep getting better. The other loop is the pacing loop. Again, these are Spark jobs. So we have a streaming job that's counting how many ads we've shown for each advertiser. And then we have another job that's essentially making sure that we are allocating ads in an optimal manner. So it's like cruise control. It's like making sure that when an advertiser says, go and show a certain number of ads, we do them in the optimal way. So we've seen a few services here, a few Spark jobs. Let's look at where the Go services, what they look like. So the first service that's written in Go is Ad Selector. Its requirements are to respond back with an ad in under 30 milliseconds. It gets an ad for every single request that goes to Reddit, so it has to deal with all of that. We've put it under a load balancer. We can scale it up when we need to. It has a lot of complex business rules around filtering and targeting the relevant ads and doing essentially what advertisers would want us to do and supporting all the features that we have on our ads platform. And then it also runs an auction. So for after all the business rules are applied, all the ads that are in contention then go through this auction process where the highest bidder gets to show the ad. We use the quality as also an indication of whether we want to show an ad or not. The event tracker is a pretty simple service. It's an HTTP service written in Go. It needs to be really fast. It doesn't do much. It just logs events out to Kafka, but it needs to be very reliable. We can't lose events here because those are very important in the feedback loops that we have. And then we have the enrichment service, which is also written in Go. It's a Thrift service that returns data to the ad selector. It has an embedded Go RocksDB database, and its latency requirements are to respond back in under 4 milliseconds. And so it basically, for every request, it makes a prefix scan in Go RocksDB and gets a bunch of data and then does some computation and aggregation and returns that out. So the idea behind embedding it with this service is to avoid extra network hops to make sure we are serving this response quickly. RocksDB is written in C++, and we have used an open source wrapper called Go RocksDB to use it in Go. So these are the three main Go services that we have in this architecture, and then we have a few other microservices that are also written in Go that are not in that diagram. So there is a reporting service that powers a reporting dashboard that advertisers see. There is a tool that we've written to do administration work on our Vault secrets cluster. And then we have a service that generates certain events that advertisers want. So we have a few microservices that we've written over the last year, 6 months or so. And like I said, this was our first time with Go at Reddit. And our experience has been great. We started with 3 engineers working on it. We now have more than a dozen, which might seem like not too many, but Reddit is not that big a company. That's like 10% or 20% of our backend engineers. So the things that we saw after using Go, we've seen increased developer velocity. We are able to get new engineers onboarded and start getting familiar with our code base and start working on it very quickly. Go's emphasis on simplicity and readability has made that possible. Also, the quick deploy times, compile times, those have been very useful as well. We've seen great performance out of the box. We've not had to do too much tuning or optimization beyond following like the best practices. This is in stark contrast to my previous experience at other places where we've built similar things on other languages. Like tuning the JVM, garbage collection, those things were pretty common that I had to do. It's really easy to focus on the business logic. Ad serving's business logic can get really complicated and often hard to understand and work with. And again, like Go's emphasis on simplicity has really helped there. Perhaps most importantly, the latency of ad serving has gone down drastically since we rolled this out. So this is a graph showing a drop in latency. We went from around 100 milliseconds, and at times it was more than 100 milliseconds, to less than 10 milliseconds. And I mean, Go played a big role in helping us do that. Cool. So we've seen how Reddit has used Go, how it's worked for us. Now let's get to the main part of the talk. In the rest of this talk is divided into 5 sections. Each section, I'm going to talk about a problem that we faced, starting from the very beginning, to talking through like how we tried to tackle it, and then leave it with a takeaway for all of you if you had to deal with similar issues, what you could do with that. So we decided that we were going to use Go, and then the first question we had was, how do we deploy production-ready microservices? Like I mentioned, we had prior art around doing this with Python. Reddit has written its own framework for running Python services, so we weren't sure how to do this with Go. We wrote an initial prototype, and that was good. It was a result of me looking up things on Stack Overflow or Googling stuff, and it worked, but we knew that it wasn't going to scale well. Metrics and logging were all over the place. The transport, so Thrift in this case, was very tightly coupled with our business logic, and we needed to find ways of having patterns that could be repeated as we added more services. So we looked around, we saw that the community has already solved this problem. So we looked at like frameworks and toolkits. I'm just going to quickly list these out. There's Go Micro, Gizmo, and GoKit were the ones that we looked at. There are a lot of them out there if you wanted to look them up. Each of these has its own pluses and minuses. Depending on what your use cases are, you might want to look at them. For us, GoKit made the most sense. We ended up picking GoKit. There were a lot of reasons. The main ones were we have to support Thrift. So GoKit was one of the few toolkits out there which was flexible enough to let us pick Thrift as a transport. We wanted something that was flexible and not very prescriptive. So again, like for example, if all of Reddit wanted to move to something like gRPC, we wanted it in such a way that we could easily switch over when we wanted to. And then we wanted to do the standard things that you would want to do when you're running microservices in production, especially at scale. We wanted good support for logging, metrics, rate limiting, circuit breaking, service discovery, and so on. And GoKit provided all of those things. There are a lot of other reasons as well. I recommend, if you're interested, check out Peter's talk at GopherCon 2015, where he introduced GoKit. And a lot of the motivations that he had for building GoKit applied to Reddit. So they kind of were a great fit. So this is what a GoKit service looks like from a really high level. This is the enrichment service that I mentioned before. So you can see at the very center there is a service interface, and there are 2 implementations of it. So we started off when we were prototyping with an in-memory implementation that would just store everything in memory and respond back. And that was good for our prototype, and then once we started using it for real stuff, we switched over to RocksDB. We still have this in-memory implementation for local testing and development for people who just want to use it for local stuff. The nice thing about having this separate from everything else is when we want to focus on the business logic, we can just change it in the middle there. It doesn't have to affect anything else. And then above that, we have middleware for tracing, logging, metrics, and a few other things. And then at the very top, we have the transport, which is Thrift. So the nice thing here is if we wanted to switch to, say, we use Zipkin for our tracing. So if you wanted to switch from Zipkin to something else, we would just have to change the tracing layer. Similarly, if we wanted to change from Thrift to gRPC, we would just change the bindings at the transport layer, and everything else would work. So this has worked really well for us. It's enabled us to have new engineers on board and start working on things. One other great side effect that this had was it gave us a good example of how to structure our code. There was a talk yesterday about how to structure Go code by Kat. I think it was a great talk. If you haven't seen it, you should check it out when the videos are posted. But before that talk, we didn't really know what the best way of doing these things was. and looking at GoKit's examples was very helpful. Now, I really like GoKit. I'm not just advocating for that. The thing I want to leave with you is if you're in a similar place as we were, you might want to consider using a framework or a toolkit that works for you. I'm not saying you should use it for every single thing that you use Go for. We don't use it for some of the not critical tools that we have in Go. But if you're going to run production services that need all of these things, like tracing and metrics and so on, it's better to use libraries that have already solved this problem rather than trying to do it yourself. So that brings us to the next problem that we had. So the next problem was, now that we've figured out that we're going to use GoKit to make production services, how are we going to roll this system out in a safe way, and how are we going to do it quickly? We needed to do it quickly for various business reasons. We had deadlines, and then our main goal was to minimize the impact on Reddit users. People who want to come to Reddit for the content, we do not want them to suffer because we are switching our ads backend. We also did not want to cause any issues with our advertisers who are spending money already on that platform. So we already had a bunch of advertisers who were using it. And then we had other internal teams who relied on us. The third-party ad server, the added complexity here was that the third-party ad server was a black box for us. We didn't know exactly how it worked. We didn't know how the auction logic worked. We didn't know what it did. So we weren't sure how we would compare to it. So we didn't want a big change in the business because of this rollout. So we realized that we needed a way to rapidly iterate and put things out in a safe way and learn from our experience. It was like an exaggerated comparison was like changing airplanes mid-flight. I don't think it's that bad, but it felt like that. And so here we have the same thing. We had a third-party ad server that our service was talking to, and we needed to build an ad server around it. So we started by injecting our first service, the ad selector, into the request path. And what we basically did was took the request from the Reddit backend and passed it on to the third party and proxied the response back. So this code did nothing else but blindly just do the same thing that we were doing before. So what this meant was we now had a way of injecting our first Go service into this path, but it was a no-op to advertisers and our users. And this also allowed us to scale it up to handle all our traffic without really doing much with it. So once we had that, we quickly added a second component to it. We called it native ad selection because it's our own. And this was like a second Go routine-like thing that was running along with the proxying to the third-party ad server. So now for every request, we would send the request both to the third party and process it internally. But we would always respond back with what the third party was sending. And we started logging both of these results. So we now had Kafka events that had for every single request, we had responses from this third-party ad server and our own, and we could run offline analysis on how we were doing. And we set up like a framework where we could quickly keep looking at how we were doing, comparing results, and building the rest of the stack around it. So then we built out all the other things. We've already seen all of these. We built all of these out, starting with stub services that didn't do much and quickly added more business logic to each. And then once we were happy with how things were looking, we transferred all the traffic over, which was essentially saying instead of responding with the third party's ad, just send back our own ad. And then once that was done, we cut off the proxying to the third-party ad server, and then we were left with the state of the system that it is in right now. So this allowed us to rapidly iterate and quickly learn from mistakes and go. A question that you might have is, where does Go really come into this? You can do this with other languages. I mean, we had Scala, Spark here as well. But the thing where Go really helped us was it allowed us to do this safely and easily. So a few reasons here. The first three are sort of related. The compiler is really fast. There's support for cross-platform compilation. So for early prototypes, we could build binaries that could run in Linux from our MacBooks and quickly push them out. We changed that once we were running things in production. But again, the self-contained binary, all of these things helped us deploy things really quickly. So our time from discovering bugs to fixing and rolling them out was like minutes. We were pushing code like scores of time a day, if not more, when we were iterating on this. And then the last thing here, the strong concurrency primitives, those helped us run these multiple auctions, switch things around, and do those in a safe way. Go routines, channels, and the select statement. So the takeaway from this experience was the rapid iteration that we needed to do was made easy and safe thanks to Go. Problem 3. Once we started running things in production, getting traffic and scaling it up, we started seeing slowness. We had a few services that were talking to each other, network glitches happen, we were deploying things very rapidly, so bad deploys could slow things down. So how do we debug slowness? How do we debug latency issues? Now, pprof is really useful. I'm not going to go into it a lot today. There are a lot of tutorials and tools out there that talk about it, but that has been very useful in profiling and looking at how we are using the CPU and memory in each of our services. Distributed tracing is something that was very useful. We did not initially have support for that on our ads side, but Reddit has always had distributed tracing through all of its other stack. So we realized that we needed to support distributed tracing. Let's quickly look at what that means. So again, this is part of our infrastructure. There's reddit.com, the backend, talking to ad selector and enrichment service. With distributed tracing, what would happen is each service would emit timing information about its processing. So the time it took to process the request, it would emit that, and that would go to a collector. We use Zipkin, and the collector would then collect it from all these services and join them together and give you like a unified view of what things look like. This is very useful in identifying hotspots and other weird behavior, and we wanted to support this. It's usually very easy. So if you have a client and a server, for Go especially, what you want to do is, on the client side, you need to extract out trace identifiers which identify a trace and inject them into the request that you're sending to the server. So that is how each trace that's emitted by a service has the same IDs and can be joined together. On the server side, you want to do the opposite, which is when you get the request, you get the identifiers from the request, and then put them in the context object and pass them around. If you are using transports like gRPC or HTTP, it's pretty straightforward. There's no reason to not do this. You can see the GoKit tracing package. So these slides will be around for you afterwards. I'll put them out so you can look at it. But this is really straightforward to do with HTTP and gRPC. But we were dealing with Thrift, so there were some problems. We saw that we need two things. We need the headers. We need some way of passing information. With HTTP, it is headers. With gRPC, it is metadata. We needed some way to do this with Thrift. And the other thing we need is we need the support of a context object. So with gRPC, HTTP, the first argument of your handlers is often the context object, and you can use it. So there are two options that we had with Thrift. One is Apache Thrift that was open sourced in 2007, and then the other is FB Thrift that Facebook re-open sourced with changes in 2014. The main differences between the two include better compression, some performance improvements, and support for headers in FB Thrift. So FB Thrift has a thing called the T-header protocol that allows you to add headers to your request transparently of the rest of the implementation. But FB Thrift does not have the context object supported yet. So we tried using this because we wanted a way of passing around identifiers transparently. We tried using it, and it kind of worked, but there were some issues. The context object not being around made our code really messy. We had to either pass around the identifiers as explicit arguments or figure out ways of injecting things into a context object afterwards downstream. And it worked, but there were certain complications, and it's kind of like, I'm not going to go into a lot of that detail now. If anyone's interested, I can talk afterwards, but the main thing to keep in mind here is this wasn't going to work in a clean way like it does with gRPC and HTTP. And then on the Apache Thrift side, it's the opposite. We have the context object was added as a supported object sometime in 2017, but it does not have support for headers. So we came up with a solution, which is to add t-headers into Apache Thrift. So this has been done for other languages like C++ and Haskell and now Python, but it wasn't done for Go. So we basically forked Apache Thrift, looked at the implementation in FB Thrift, and added that to a fork of Apache Thrift. And this fork currently lives here. I'm hoping to get through the contribution process and merge it upstream so everyone else can use it as well. So once we had this, we could write wrappers. So here's an example client wrapper that does what gRPC and HTTP do, which is it extracts out the trace information from the context object and then adds it to the request, the headers. The t-header writer here, the t-header reader writer is the thing that gets injected into. And on the server side, we did the exact opposite. So we now have the information extracted out from headers and then injected into the context object so it can be passed around. And this code examples are on this repo, so you can check those out later if you're interested. This is great. This is what that means. So we now have like 3 services that have trace information propagating through them. So this is now working. This is very useful in debugging latency issues. So the sort of takeaway from this is tracing is important if you care about latency. And it's hard with Thrift and Go. And we've had to spend some time trying to figure it out. There are ways of making this easier now, and hopefully it'll be something that other people can use as well in the future. So we spoke about latency. Let's talk about what to do. Like, we can debug latency when things are slow. We can debug why response times are slow. But we also want our services to handle them gracefully. So in our case, we absolutely did not want our users to suffer if there was slowness. We prefer not showing ads or taking too long to show ads. So the 2 kind of things that were important for us, one is don't make users wait for too long, and the other was don't waste resources doing unnecessary work. So the first is easy. So when we built our first prototype, we built it for the happy path. We expected everything to work. And then we quickly realized that's not going to happen, so we needed to add timeouts to our services. And in this case, like here's an example of adding a deadline to the context object and then making sure that you kind of pass it through and you exit early if that deadline expires. And then this is good. We did this, and so this is a graph on the ad selector side. That's the first service in the ads services. And so this is a graph showing how long it was taking us to get the responses from the enrichment service. And you can see that it's topping off at 25 milliseconds when we had timeouts, or when there was slowness. And what this means is we are degrading, but not letting our users wait too long. So this is good. But this wasn't enough. This is the same graph at a slightly different time, but on the other side. So on the enrichment service side, the time to process request, it was around 70 milliseconds. So what does this mean? It means that, like the service was using resources to do work where the client had already timed out. So it's like if your manager tells you to do something, you spend a few days working on it, and then when you're done, you find out that he needed it 2 days ago, doesn't need it anymore. You wouldn't like it, right? This is like that. We are wasting resources doing something that could have been used for more useful things. So what we want to do is pass deadlines around. So here's an example of like, if you wanted to do this with HTTP, you would do the same thing as we had done before, which is add the timeout or the deadline to the context object, and then include it in the request, and it would just, the library would take care of everything else. That's great. It's the same with gRPC as well. But again, Thrift is where things get a little hard, which we saw. So here is this is not our code, this is the implementation of the Thrift server. So the server is running an accept loop. It's waiting for connections. And when it gets a connection, it spawns off a go routine. There's no context object used right here. Even Apache Thrift, which has the context object, all of that is done sort of downstream to this code. What this means is if the client times out, this go routine doesn't really know that. It doesn't exit. So this isn't great. There are ways of fixing this. We didn't really have the time of doing that, but we kind of worked around it. The first thing we did really quickly was just add the deadline to the Thrift payload. So while we make the request, in addition to the sort of application level things, we also mention that, hey, if you don't respond back in this time or by this time, we will exit. And this can be used by the server to enforce timeouts on its side. But this isn't great, because if you wanted to do this, you'd have to do it in all endpoints that you're adding across all services. So again, this is where we've realized that using the headers really helps. So we use a special header for the deadline to transfer that information from a client to the server and propagate deadlines around. And this means that now, like on the enrichment service side, we also see latencies that are kind of similar to what we see on the other side. So the takeaway here is, if you care about these things, if you don't want your users to wait too long, if you don't want to waste resources, use deadlines within and across services. This brings me to my last point. We had three things. We had a need to iterate quickly and implement something quickly. The business logic was pretty complicated. And then we also had a strict latency SLA. So these three things meant that it was hard to deploy things quickly and make changes, add complicated code without violating the SLA. We had a few cases where we had to go through this sort of rabbit hole of deploying a change and then trying to figure out why it broke things, and then came back and fixed it, and so on. So we realized we needed a few processes or some tools that would allow us to not let that happen too often. So we used two pretty commonly used techniques. We used load testing. There's a tool called Bender, which is open sourced by Pinterest. We use this library to build load testers for every service that we write. So every Go service that we have a Marathon app running in our Mesos cluster that can be used by developers and use it for load testing. And here in this example, you do some setup, create some request, and call bender.loadTestThroughput. This will test the throughput. You can specify how much you want. Bender claims to scale as much as about 7,000 requests per second from one machine. And then you can also record it, and then you print it, and it looks something like this. So you can see the timing information, how long things are taking, how many errors are happening. And this has been very useful in avoiding issues and having them impact production. This has given our developers the ability to test out their complicated changes in a safe environment and iterate on those quickly, fix them, optimize things, and move on. And there's a link to Bender here, if anyone's interested in looking at it. It has support for HTTP and Thrift. It does not support gRPC yet, but I think that's pretty easy to add if anyone wants to do it. And then the last tool we used is pretty common. We use benchmarking a lot. We write benchmarks with all our unit tests, so all the sort of common, all the critical things that we have, we make sure we have benchmarks. Here's an example. That's over our native ads fetching call. And then the response or the result of running the benchmarks looks something like this. You see timing information and allocations and so on. And this has helped us in a couple of ways. It's helped us prevent degradation or making changes that slow things down. It's also given us the ability to look at how things have changed over time. And then we've also used benchmarks to make trade-off decisions about implementations running benchmarks. So the lesson here is load testing and benchmarking is really easy with Go. You should use it. So that brings us towards the end. Let's just quickly recap. We started with looking at how we ended up with using GoKit, how it has helped us. And the takeaway is you should try to do that if that is something that is important to you. We spoke about our process of rolling out this new ad server and how Go has made our rapid iteration safe and easy. We spoke about distributed tracing, why it's useful, how it was hard with Thrift, and some things you can do to make it better. If you care about not timing out and wasting resources, use deadlines. And then lastly, use load testing and benchmarking. So to conclude, Go has been instrumental in helping us build and scale this new ad server. It's been really easy. We could do it very quickly. And Go has been responsible for that. We've started off with about, like I said, 2-3 engineers working on it, one team. Now we have a few teams using it, and hopefully it's going to keep growing. We shared some takeaways that might be useful from our experience, and maybe if you're new, try using them, maybe one of them in the next time you build something in Go. That's all for my talk. Thank you for listening to me. If you have any feedback or questions, my Twitter handle is up here. Thank you.